All right, these are our essential questions. You can make a regular tessellation from an equilateral triangle, a square, or a regular hexagon. Explain why these are the only 3 regular tessellations that are possible. Our goals, like we said before, were to be able to identify a tessellation and its type, and to be able to create your own tessellation. All right, here we go with our vocabulary, and I'm going off of 12.6 in our textbook. It is page, scroll down, 863. Not that you have a book there in front of you, but I just wanted you to see what it looks like. There we go, 12.6, and you can see our vocabulary words. Our first one is translation symmetry. A pattern has translation symmetry if it can be translated along a vector so that its image coincides with the pre-image. Remember, we talked about a vector being basically a straight line. So a translation symmetry, it means that the image can be slid next to each other over and over again, and it still have the exact same pattern. You can see translation symmetry in these 2 example pictures where the bird's been slid over, and you can also see it here where the little stair steps have been slid over. Let me show you another one. It's got like a cat all cut out, and you can see that it has translation symmetry. Okay, even though the original image was kind of funky looking, it's just translated up or slid up. So translation symmetry is when an image is translated along a vector so that it coincides with the pre-image. Let's scoot our paper down here. All right, so that's translation symmetry. It can be translated along a vector so the image coincides with the pre-image. Remember, you can pause and rewind as many times as you need, so I'm not going to wait for you to write. A Friend's pattern is our next vocabulary word. Notice I'm putting all my words on the left of my Cornell notes, and then I'm leaving room for my definitions on the right. That'll help you study. A Friend's pattern is a pattern that has translation symmetry. I'm getting tongue-tied today. Has a translation symmetry along a line, which is also what a translation symmetry is. So a Friend's pattern is just a fancy name for it, a special type of translation. You can see those both down here in example 1 under the art application. You can see they go straight along a line. Our next word is glide reflection symmetry. You'll remember from our previous lesson that a glide reflection is where the image is translated or slid over and then reflected. Instead of saying glide reflection, they could have also said translation reflection, but that's just a mouthful. You can see a glide reflection symmetry in the second picture right here. I'm going to circle this so you can see this picture here, where they had taken this little stair step and they slid it over and then they flipped it to get the second image up here. All right. You can also see the same thing here where they slid the image and then reflected it up. Slid the image and reflected it up. Our next word is just tessellation. What in the world is a tessellation? Well, that's what we're talking about. Tessellation or tilting, or tilling, is a repeating pattern that completely covers a plane with no gaps or overlaps. You can see it here where these color-coded angles, they have kind of a funky looking quadrilateral with slanted sides, flipped and rotated so that each time it meets, all the angles are different. You can see they have a yellow, green, blue, red in every corner. And it's a tessellation. All right. Then our next word is regular tessellation and semi-regular tessellation. And we're going to do these together. Get down to those definitions here. There we go. A regular tessellation is formed by congruent regular polygons. So regular tessellation, regular polygons. And you can see an example of one where they've used an equilateral triangle and flipped it and then slid it. They slid it down and then reflect, and then slid it down and reflect, and slid it down and reflected. The image on the left. And then a semi-regular tessellation is formed by 2 or more regular polygons. So if there's more than one shape, it's automatically semi-regular. But it's only semi-regular if those polygons are regular. polygons, meaning all sides congruent, all angles congruent. That's the definition of a regular polygon. So you see our square and then two different equilateral triangles here. You can also see a couple other images, just get a couple more pictures of them. You see our regular, where they use 3 different hexagons over and over again. They colored them 3 different colors just to help you see it. It's still exactly the same hexagon. Neither regular nor semi-regular, because they used a non-regular triangle. It's an isosceles triangle. And this one's semi-regular because they used a regular triangle and a hexagon. Okay? There we go. And that's all your words. That's the important thing you need to know. Remember, later on this week, we're going to be creating our own tessellations, kind of like this one that you see with the cat. You're going to be cutting out shapes and sliding them. If you'll look down in the notes of this video, there's a link to a playlist of various tessellations shown on YouTube. In fact, one of them even shows the step-by-step directions that we're going to be using to make our tessellations. But you're also going to get to add extra steps by rotating, flipping, and translating. You're going to want to use all those steps. All right, and I will see you in class.